Today we are going to continue with our similar figures unit, and today we are going to be talking about real-world problems and how to solve them when given similar triangles or triangles intersected by 3 or more parallel lines. Let's first talk about some skills that we need to use in order to solve these real-world problems. These are the steps that we want to follow. We first want to draw a picture if one is not given. We want to set up a proportion. Make sure that the ratios match. For example, if the biggest triangle is on top of one ratio, then the biggest triangle should also be on the top of the other ratio. We're going to solve by cross multiplying, and don't forget to use those units of measure at the end. Let's go ahead and start to take a look at some examples. First, we have this picture of this gentleman, Jim, who is looking at a mirror to look at the top of this tower. So to estimate the height of the Jinmao Tower in Shanghai, a tourist sights the top of the tower in a mirror that is 87.6 meters from the tower. The mirror is on the ground and faces upward. The tourist is 0.4 meters from the mirror, and the distance from his eyes to the ground is about 1.92 meters. How tall is the tower? Let's first decide what information we are going to be using. We have a vertical distance, which is the height, compared to a horizontal distance, which is the distance from him to the mirror or the mirror to the tower. So that is the way we are going to set up our ratio. So let's take a look in our few sentences to figure out what we can underline to help us. We know that the mirror is 87.6 meters from the tower. That means we have a horizontal distance for the mirror. We know that the mirror faces upward and that the tourist is 0.4 meters from the mirror. So the tourist has a horizontal distance of 0.4. We also know that the distance from his eyes to the ground is 1.92 meters. That's his vertical distance. And we are looking for the height of the tower, which we will call x. We are now going to cross multiply. 0.4 times x is equal to 1.92 times 87.6. 0.4x is equal to 168.192, and we will divide by 0.4 and find out that x is 420.48 meters. That is the height of the tower. Let's take another look at an example. Here I have a figure given of a cross-section of an attic of a house. I have a vent pipe here that comes through the floor 6 feet from the edge of the house. What is the distance x on the roof from the edge of the roof to the vent pipe? So we are comparing a small triangle here with a larger triangle here. And we are actually given the horizontal distance, that's the distance across the bottom, and the hypotenuse distance. So we are going to compare the hypotenuse with the horizontal distance. So I know that the hypotenuse of the small triangle is what we're looking for, and that the horizontal distance of the small triangle is 6. I know the hypotenuse of the roof is 18, and the distance from the edge of the roof to the center is a combination of 6 plus 9, which is 15 feet. We are now going to cross multiply. 15x is equal to 6 times 18. 15x is equal to 108, and we will divide by 15, and we know that the angle distance from the center of the pipe to the side of the house is going to be 7.2 feet. One more example. Thales was the first mathematician to use geometry to measure the height of a pyramid. He found that when a stick that was 2 paces high had a shadow of 3 paces long, then a nearby pyramid had a shadow of 239 paces. So we are comparing paces to shadows. So we know what ratio we're going to set up. So we're going to compare the stick and the actual pyramid. So the stick has a pace of 2 and a shadow of 3. The pyramid, we're not quite sure what the pace is, so we'll call that x, and it has a shadow of 239. And if I'm not sure, I can draw a picture to represent the situation by drawing 2 triangles. So we're going to cross multiply. 3x is equal to 2 times 239. 3x is equal to 478. And when we divide by 3, we know that x is 159.3 paces. And that is the height of our pyramid. So if one pace is 3 feet, how tall will the pyramid be? So we're going to set up another proportion to show that one pace is equal to 3 feet. Well, if I know that I have 159.3 paces, and I want to know how many feet that is, then I know that x is equal to 3 times 159.3, which tells me that the pyramid is 478 feet. Now we're going to take a look at if we have parallel lines. So if a line is parallel to one side of a triangle and intersects the other 2 sides, then it divides the sides into segments of proportional length. What that means is that if I have 2 parallel lines, AC is parallel to DE, then I can say that AD is proportional to DB and CE is proportional to EB. I can also write a converse, which says if we know the proportional segments, then we can state that the lines are parallel. So we're going to take a look at a couple of examples. So here I have 2 examples where I know in fact the lines are parallel because I have the symbols with the little triangles here. So I'm going to set up my proportion, comparing my proportional sides. So x compares with 15 and 14 compares with 12. So x is proportional to 15 and 14 is proportional to 12. We cross multiply. 12x is equal to 210, that's 15 times 14, divide by 12, and x is equal to 17.5. My other example, number 2. Now you'll notice that in number 2, I have an entire length here. I need the proportional side, so I need to find this missing side by subtracting 45 from 55, and I find out that it's 10. So now I can compare x proportional to 36 and 10 proportional to 45. Cross multiply 45x is equal to 360. Divide by 45 and x is equal to 8. We're now going to take a look at the converse where I'm given the proportionals and I want to determine if the lines are in fact parallel. In order to do this, I actually have two options. I can use a scale factor method, making sure that my scale factors are both the same, or I could cross multiply, making sure that my cross products are the same. I'll show you both methods in number 3. So if I compare 11 to 15.4, because they are said to be proportional, and 10 to 14, I know that both of them simplify to 5/7, which means that they are proportional, and therefore I can say that MN is parallel to JL. I can also use the cross products by setting up 11 proportional to 15.4 and 10 proportional to 14 and cross multiply. 11 times 14 should be the same as 10 times 15.4. And they do in fact both equal 154. So therefore my lines are parallel. You can choose whatever method works best for you. I'm going to continue with the cross products. So in number 4, you can see that I have an entire side, so I need to subtract. So JL is 54 minus 24, which is equal to 30. Now I can set up my proportion of 30 proportional to 24 and 37.5 proportional to 30. And when I cross multiply, 30 times 30 is 900. And I'm hoping that 24 times 37.5 is also 900, and it in fact is. So therefore, we can say that MN is parallel to JL. Our last skill for this section is when we have 3 or more parallel lines that are intersected by 2 transversals, then they cut off the transversal proportionally. So I would state that AB is parallel to CD is parallel to EF. And these are lines. So therefore, AC is proportional to CE and BD is proportional to DF. Let's take a look at 2 examples that use this skill. So here I know that the lines are parallel. So in number 1, I have all of my individual segments. So I'm going to set up my proportion of 45 proportional to 18 and 52 proportional to X. When I cross multiply, I have 45x is equal to 936. And I divide by 5, and I find out that x is equal to 20.8. In number 2, I'm actually missing this space right here that I need to find first by subtracting 18 from 32, and I know that this becomes 14. So now I have all of my proportional pieces. 27 is proportional to x, and 18 is proportional to 14. So when I cross multiply, I have 18x is equal to 378. And when I divide by 18, x is equal to 21. Now I'd like for you to pause the video and try these 2 examples on your own. These deal with the real-world problems. Now that you've had some time to work through them, let's take a look at them together. The biggest thing here is to draw a picture representing the situation. We have a flagpole that is 28 feet tall, and it casts a shadow. That means the sun is over here to the side, and it's casting a shadow that's 15 feet long. That's a little long for a shadow. Let's shorten that. So we're creating a little triangle. Then we have a tree that is casting a shadow. The tree is casting a shadow of 21 feet. And I want to find the height of the tree, so we'll call that X. So we have the height of the flagpole compared to the height of the tree. I'm sorry. The height of the object compared to its shadow. So when we cross multiply, we have 15x is equal to 588. And when we divide by 15, we find out that x is 39.2 feet. And this is the height of the tree. Practice problem number 2 says that Cindy had her picture taken standing next to a giant Duke dog statue. In the photo, the image of Cindy is 3 inches tall and the statue is 15 inches tall. So Cindy is actually 48 inches tall. What is the actual height of the statue? So, and we're going to talk about in feet in just a second. We know that Cindy height versus her real height. And we're going to compare that with a statue picture compared to the statue height. So Cindy's height in the beginning is actually going to be the height of the picture. So we're going to set up our proportion. 3 compared to 48 is equal to the statue's picture height, which was 15, and we don't know the height of the actual statue. So we're going to cross multiply 3x is equal to 720. Divide by 3, and we find out that x is equal to 240 inches. So this is in inches for the height of the statue, but it's actually asking me for the statue in feet. So I need to know that there are 12 inches in a foot. So I'm going to take the number of inches and divide it by 12. And that's going to tell me that the statue is 20 feet high. Go ahead and pause the video again and try these 2 examples. Now that you've had time to try them, let's take a look. These are dealing with our proportional parts that are separated by parallel lines and transversals. So we have that 12x, 12 minus x, is proportional to x plus 3, and that 6 is proportional to 4. So we can simplify the 6/4 or leave it as is, and I'm going to go ahead and leave it this time. So we have 6 times x plus 3 is equal to 4 times 12 minus x, making sure that we distribute both the 6 and the 4 inside of their parentheses. 6x plus 18 and 48 minus 4x. We are going to move the x to the same side, so we're going to add 4x to bring it to the left. So we have 10x minus plus 18 is equal to 48. Now we're going to subtract 18 from both sides to isolate our variable. So 10x is equal to 30, and divide by 10, and we find out that x is equal to 3. In our last example, we are given the total side here, so we need to subtract 15 from 27, and we know that that side is 12. We also are looking for the entire piece on the bottom, and we're actually given that value, and we're looking for a piece. So I can actually ignore the 12 that I just found and compare the biggest side with the smaller piece. So I have 15 compared to 27 is equal to x compared to 63. When I cross multiply, 27x is equal to 945, and divide by 27, and I find out that x is equal to 35.